Hello everyone. So today we'll be solving a LeetCode medium problem, distribute candies among children too. The problem states that we are given two positive integers n and limit, and now we need to return the total number of ways to distribute n candies among three children such that no child gets more than limit candies. So for example, here n is equals to 5 and limit equals to 2. So if we try to we need to give it to three children. So if we try to give the first children zero candies, we can give the second child at most two candies, and the third child at most two candies. So here were not able to distribute all five candies, so this way is not possible. So for example, if we give the first child one candy, then maybe we can give the second child two candies and the third child as also two candies. So this way is possible. uh, let's try to give the first children two candies, then we can give like second children first candy and then the third children. So this is also possible. Then if we did, then we can give two candies to a second child and one candy to the first. So these are the three possible ways of distributing the n candies. Here n was 5 with limit as 2, so here the output was 3. So we can see like the problem generally breaks down into we need to find interior solutions for this particular equation, like x plus y plus z should be equals to n, and this constraint should be followed, like each x y z can lie between 0 to limit. So the brute force way for this to go with this problem would be to fix x, like x, since it can go to x less than equals to limit. So we can fix x, then we can fix y as well, and then we'll be easily getting the z, which will be n minus x plus y, the number of candies that we have already given. Now if this z follows, like z is greater than equals to 0 and then z is less than equals to limit, then uh, we will increase our base variable by 1, and in this manner we will be able to find out all possible ways of distributing. Now will means this x, since nothing is mentioned about the constraints between relation between n and limit, so it may be possible n is less than limit, right? So if n is less than limit, then we can only give like this, we will need to modify this constraint to minimum of n comma limit, because if limit is 5 but we have n equals to 2 candies only, then we cannot give 5 candies to any children, right? So hence we'll update this less than equals to limit constraint with minimum of n comma limit constraint, and hence the code would look like something this, like where we have fixed the first child, try all possibilities for child 1 from I equals to 0 to I equals less than equals to limit. We can also modify it to minimum of n comma limit, then modify the second loop as well to minimum of n comma limit, and then we'll find out the third child, which is n minus I minus j, which was x and y here, and we'll see if the constraints are followed, then we'll increase the count by 1. And so as we can see, this is of the order of limit square, and since limit is up to 1e6 here, means constraints are up to 1e6, so this will be of the order of 1e12, which will obviously give us daily here. Hence we need to modify our approach to something of the order of big of limit or big of n, or maybe n log n or something like that. So how do we move forward? So what if we tried to, instead of here we fixed the number of candies for two childs, but what if we need to avoid this second loop that we are using here? So what if we just fixed for the first child and then tried to find out some range of possible values for the second child on the basis of fixing first child only? So we fix the first child, alright. So now we will iterate through all possible values x for the first child, which will be ranging from x to minimum of n comma limit, right? Now what we will get for y means the remaining values that remaining candies will be n minus x. We have given x candies to the first child. So once x is chosen, the problem reduces to distributing the remaining candies to the second and third child, and the remaining candies is n minus x. Okay. Now we have n minus x means our candies remaining. We need to satisfy the following constraints. So if we give y candies to child 2 and z candies to child 3, then y plus z should be equals to r, and this constraints should also be followed. Like each child should not get candies more than the limit. So what if we like try to find out a particular range of possible values for the second child for y, or we can also find for the third child as well. But here what if we try to find out possible range of values uh, with the number of candies that we can give to the second child. So let's try to rewrite the equations here. So instead of z, let's replace it with r minus y. So if we replace it with r minus y, we will get like r minus y is less than equals to limit and greater than equals to 0. So this means y should be less than equals to r, the left hand side, and this means y should be greater than equals to r minus limit, right? And since y is less than equals to limit as well, hence this derives that y should be less than equals to minimum of r comma limit, right? And since y is greater than equals to 0 as well, hence y should be greater than equals to max of 0 comma r minus limit, and here r is n minus x, right? Hence we have got a range for y, that is y is greater than equals to max of 0 comma n minus x minus limit, and it is less than equals to minimum of n minus x comma limit. So we have find out a range for y which is from L to R, where L is this and R is this, and we can give any value which lies in the range uh, L to R, and the constraints for the number of candies that will give to Z will satisfy the constraints, right? So hence all possible ways of giving means from this range is possible, and the number of values from L to R is R minus L plus 1. Hence there are R minus L plus 1 ways to give candy to second child. So hence we will follow this approach of finding out means fixing x for first child, and then finding out this range for the second child, and the number of ways would be r minus l plus 1. Now one more thing we need to satisfy is suppose we have given x candies to first child, then the remaining was n minus x. But what if this n minus x is greater than the maximum candy we can give to second child, which is limit, plus maximum candies we can give to third child, which is limit as well. So what if this n minus x is greater than equals to 2 into limit? Then what? So in this case means there does not exist any way where we give x candies to the first child and there exists a valid distribution. So hence we can skip the iteration in this case. Okay. So this is the approach that we'll try to follow, and using this we have avoided the second loop that we are using here, and now the complexity can be means would be of the order of big of limit. So let's see the code here. So as you can see, we have declared a variable base. Now we'll move x from minimum of n comma limit. Now remaining is n minus x. So if remaining is greater than equals to 2 times limit, which was limit plus limit, means both second and third child gets limits candies, and still the remaining is greater than that, then there is no way possible. So hence in that case we'll just continue or skip the current loop. Now we'll assign the remaining n minus x candies to two childs. So the maximum value that can be assigned was minimum of n means y was ranging from minimum of n minus x comma limit and greater than equals to max of 0 comma n minus x minus limit. Okay, so this is what we are finding out here. The L is max of 0 comma n minus x minus limit, and R is minimum of n minus x comma limit, and the number of ways would be the number of values in the range L to R, which is R minus L plus 1, and hence finally return the ways. So this would be of the order of big of limit, which is acceptable here because the limit is up to 1 is x only. So this this for the scope of this problem, you can stop at this approach and move forward. In interviews also, I don't think they will try to means ask you to optimize further, but since as you can see this may get converted into a PNC problem, like we need to distribute n candies among three children so that no child gets more than limit candies. So there are constraints on the limit and such that x plus y plus z is equals to n. So maybe some form of PNC can be used here. So for further optimization, there exists means another approach using means combinations. So now I will be discussing that. Means for the means for the scope of this constraints, the solution has already been discussed. But if the constraints were of the order of suppose 118 or more than 118 or 109, then this means approach that we have discussed above would not work obviously. So hence for that we'll try to see if we can use this permutation and combination and find out some solution. So the solution is we have a subset, like let's try to find out. Suppose we had only n candies and k children, and we can also give empty candies as well, right? So we need to suppose there was no constraints. So if there were no constraints, then the number of ways to distribute n candies among k children with means 0 candies allowed would be what? Like we have n candies here, so on. And you might have studied in 11th and 12th, you generally try to place k minus 1 walls in between those candies, right? But here as we can see, a particular child can get 0 candies as well. So these two walls can exist together also. So if the second child gets 0, first child will get this and third child will get this. So hence here we try to find out the solution using, suppose we have these n candies and we have k minus 1 walls. Okay, now we just need to arrange these means n plus k minus 1 objects into all possible ways, and that would be the number of ways to distribute. So what would be what it would be? It would be factorial of n plus k minus 1. Would be dividing it by the factorial of this means duplicate objects as we do in PNC. So it would be factorial n into factorial of k minus 1. As we can see, this is simply n plus k minus 1 c k minus 1. And now here we have k equals to 2, so this reduces to n plus 2 c2, right? So means if no constraints, then the ways are n plus 2 c2. Now since we need to apply this constraint of less than equals to limit, what if instead of like finding out ways where we satisfy this condition, we subtract those cases which violates the condition, right? So since suppose this is the overall set of unrestricted constraints S, so we need to find those cases, means total equals to val, means total minus invalid, right? So this total is basically n plus 2 c2 here. Alright, so this formula we will be finding out n plus 2 c2, and now we'll be subtracting the invalid cases that we'll get. And now how invalid cases, what are the invalid cases? So any one child gets greater than limit candies. Anyone. Suppose like I will try to explain it using a Venn diagram here, right? So suppose this is S, and we need to now subtract the invalid cases. Now either child 1 can means violate the condition, or child 2 or child 3. So let's denote them by A, B and C. So we'll have those cases of A, violating cases B as well as C, right? Now what would be the union of A, B and C? Here these are A, B and C, which represents invalid cases. So total valid cases would be S minus A union B union C, right? Because this represents the overall set without any constraints, and this represents the invalid cases. Now we need to find this A union B union C. And what is A union B union C? If you recall, so it is simply A plus B plus C minus A intersection B plus A intersection C plus B intersection C and plus A intersection B intersection C. And what A, B and C denotes here? That A or B or C means violates the condition. That means uh, greater than limit candies he gets, right? So now we need to find this A plus B plus C, then A intersection B, A intersection C, and this, and then. So let's try to find the first values. Summation, suppose I denote it by summation mod A. Alright, so this can be rewritten as summation mod A minus summation mod A intersection B plus mod of A intersection B intersection C. This is what A union B union C is currently. Now we need to find out summation mod A. So this means like we will violate, means at least, means any one child will violate the condition, right? So to violate the condition, we'll give first child x equals to limit plus one candies, right? So if we give the first child limit plus one candies, then the first child has violated the condition. So remaining would be n minus limit plus one candies, right? Now again the same problem remains. We can redistribute these remaining candies to the three children because we have already violated the condition, and the means the formula of distributing n candies to three children was n plus 2 c2 here, right? So hence the new form for here formula here becomes, the formula was n plus 2 c2 here, and here n is n minus limit plus 1, right? So it would be n minus limit plus 1 plus 2 c2, which is simply n minus limit plus 1 c2, right? So this is summation mod a. No, since we can only also give, means we this the child who will violate the condition, we can also choose it in three ways, right? 3C1 ways. Hence the overall summation mod a would be 3 into this value, n minus limit plus 1 c2, because we initially need to choose a child who violates the condition as well. Now let's try to find out summation a intersection b. This means that two children have violated the condition. So let's give x, means first child, as limit plus 1 candies, second child also limit plus 1 candies. So remaining would be n minus 2 into limit plus 1. Now again we can redistribute this remaining candies to 3 children in any way possible. So again it would be n plus 2 c2 only, and we'll put this value here, so it becomes n minus 2 into limit plus 1 plus 2 c2, which is simply n minus 2 into limit c2, right? And again we have like means since there are 3 children and we need to choose any 2 children who violate the condition, so it will be 3c2, which is 3 only. Hence we'll need to multiply this by 3 to account the possibilities of choosing 2 children who will violate the condition at the start. So hence summation a intersection b is 3 into n minus 2 into limit c2. Now we need to find out, means we have find it out summation a we have find out, summation a intersection b we have find out. Now we need to find out a intersection b intersection c. That means we need to find out a intersection b intersection c. That means all the childs violate the condition. So we will get x as limit plus 1 condition, limit 1 candies, y also limit plus 1, and z also limit plus 1. So remaining would be n minus 3 into limit plus 1. And now we need to distribute it among 3 children. So Vs would be n plus 2 c2, which is n minus 3 into limit plus 1 plus 2 c2, which is n minus 3 into limit minus 1 c2. This is a intersection b intersection c. And hence the overall result was s equals to, is valid equals to total minus invalid, which is n plus 2 c2 minus invalid. And invalid was summation mod a, which is 3 into n minus limit plus 1 c2. So it would be 3 into n minus limit plus 1 c2. Then we would subtract, what will subtract? 3 into n minus 2 into limit c2. So it is 3 into n minus 2 into limit c2. And then we need to add a intersection b intersection c, which is n minus also here also here do we need no, so here it would be simply n minus 3 into limit minus 1 c2. So this would be the overall formula that we'll use to like solve this problem. Now you might be wondering, what if like this n minus what if 3 into limit is greater than n, then this value will become less than 0. So in this case, so like we can create a simple function of like ncr, and if this like n is less than 0, we can simply return 0, right? And since means this r here is 2 only, so like n plus 2 c2 is simply uh, means n c2 is simply n into n plus 1 by 2, sorry, n into n minus 1 by 2. So hence we can like find out this product in constant time. Okay, so just we'll be calling this ncr function 4 times, and if the value n is less than 0, we'll simply return 0, or we'll return this product. So I hope like you get how we derived the result, how we excluded those cases which violated our conditions, and this was our valid scenario, means other than the a union b union c. This is what we are trying to find, and we have succeeded in finding it out. You means you can try to like derive it on your own so that it gets into your head. Like it's mostly PNC from 11th and 12th. So I hope you are able to grasp the concepts here. Let's try to see the code as well. Here's the code. We have means a distribute candies function where total ways is n plus 2 c2. Then we'll subtract the means n minus limit plus 1 c2, what we discussed below, the same formula. Then n minus 2 into limit c2, and then 3 n minus 3 into limit minus 1 c2. And the cal function here would be this, the long cal, where this cal where we'll call for x, and if x is less than 0, we'll simply return 0, or we'll return the x into x minus 1 by 2. So let's try to submit this code and see how well it performs. Before that, let's try to submit the code of uh, complexity big of limit, and then we'll see how well the constant time solution performs. So as you can see, like this beats only 28% of the runtime, and let's try to run this code on it. Okay, it runs fine. Let's try to submit it. As you can see, like it beats most of the runtime, and since we can also analyze the complexity, which is of the big of 1. Yeah, so I hope like you get the logic, and means finding it out in a constant time will definitely not be a medium problem here. It be tagged as hard only. So if the constraints here were of the order of 180, and if this problem means appears in upcoming constants with the modified constraints, then you will be able to solve it. So that was it. I hope you got the logic of all the approaches, and if you have any doubts, feel free to comment down, and I will be happy to respond. Thank you for watching.